Hello and welcome to The Daily Space. I'm your host, Dr. Pamela Gay, and we are here to put science in your brain. Today we're going to do a special episode focusing on the 2020 Decadal Survey on Astronomy and Astrophysics. Normally released every 10 years, these mammoth reports are the work of hundreds of researchers who collect and distill feedback from the entire astronomical community on topics ranging from what are the most important research questions, what is the most needed instrumentation, and how do we need to work to improve our field. In a perfect world, funding agencies like the National Science Foundation and NASA will use the findings in this report to set long-term priorities, although we often have seen that presidents and Congress are likely to put their own spins on things when setting budgets. Started in late 2018, this decade's report is coming out late due to problems ranging from the 35-day government shutdown that spanned from late 2018 to January 2019 to the COVID pandemic. Released November 4th, this 589-page document has been a lot to digest. And in this episode, I'm going to do my best to bring you highlights on how the astronomy community wants to focus its exploration in our universe for the next 10 or at least 8-ish years. Scientifically, it's recommended that efforts focus in 3 broad themes. And here I quote from the report: worlds and suns in context, cosmic ecosystems, and new messengers in new physics. Put another way, things are broken down into solar systems in context, the galaxies and broader universe the solar systems are in, and the weird physics that lets us study the universe with things other than light. According to the report, the science theme of worlds and suns in context captures the quest to understand the interconnected systems of stars and worlds orbiting them, tracing them from the nascent disks of dust and gas from which they form, through the formation and evolution of the vast array of extrasolar planetary systems, so wildly different than the one in which Earth resides. In defining how to advance this new research forward, defining pathways to habitable worlds is put front and center, and I quote, "with the goal of trying to discover worlds that could resemble Earth and answer the fundamental question, are we alone?" End quote. It is time to fund research and instrumentation necessary to study planetary atmospheres, to look for biosignatures of life altering the world it lives on. And this includes looking ahead to looking for planets transiting the most common stars, cool red M dwarfs, using the James Webb Space Telescope when it launches. The importance of looking for life is articulated in a way I have to share. Quote, "If planets like Earth are rare, our own world becomes even more precious. If we do discover the signature of life in another planetary system, it will change our place in the universe in a way not seen since the days of Copernicus, placing Earth among a community and continuum of worlds. The coming decades will set humanity down a path to determine whether we are alone." End quote. In looking at cosmic ecosystems, the Decadal Survey reminds us, a major advance in recent years has been the realization that the physical processes taking place on all scales are intimately interconnected, and that the universe and all its constituent systems are part of a constantly evolving ecosystem. This quote reminded me that Sagan once said that to build an apple pie, you have to first build a universe. Here, the Decadal Survey reminds us that to understand our solar system, we need to understand how to build a galaxy. The priority area for research in this area is unveiling the drivers of galaxy growth and understanding how our universe evolved from the slight fluctuations in mass we saw after the formation of the cosmic microwave background to the amazingly diverse web of structures we see today. The survey explains that the new messengers and new physics theme captures the key scientific questions associated with a broad range of inquiries, from astronomical constraints on the nature of dark matter and dark energy to the new astrophysics enabled by combined observations with particles, neutrinos, gravitational waves, and light. And the survey goes on to say that of all these weird new things, we as a field should focus on new windows on the dynamic universe and looking at how some of the most energetic events in the universe, like the collisions of black holes and explosions of stars, can be studied not just with light, but also with neutrinos and even gravitational waves. Understanding how to do it and building the infrastructure necessary to succeed at this kind of multi-messenger astronomy is seen as one of the most important areas for astronomy research. After the break, we'll be back to look at the instruments the Decadal Survey recommends building to make this science possible. Stay tuned. With the release of the 2020 Decadal Survey, astronomers are getting a taste of what future spacecraft and ground-based observatories are being labeled as a priority to build. One of the most exciting parts of this Decadal Survey is the call to maintain a steady stream of smaller and mid-sized projects that are regularly competed and can be designed to reflect the changing needs of the field, as both new technology is developed and new discoveries are made. This flexibility has been somewhat missing in the past decade, where massive projects like JWST, the Atacama Large Millimeter Array, the Large Synoptic Survey Telescope, and the 30-meter telescope all took priority and emptied budgets. This regular cadence also has the benefit of allowing new generations of astronomers to get opportunities to be part of a new program from beginning to end and get the experience they'll need to be leaders on the next generation of missions. When projects like JWST take more than a generation from planning to eventual launch, you don't really have a chance to incubate new talent that is still young when they start building their own ideas. It's exciting to imagine a return to regular new projects coming into fruition as graduate students go from helping to build instruments to operating new systems as postdocs and proposing the next generation while still early in their career. One of the things we've talked about a lot around here is the end of the Great Observatories program. And if you don't know about the Great Observatories program, I'm actually going to recommend a podcast that I do with Fraser Kane, the producer of Universe Today. It's called Astronomy Cast, and we've talked recently about the Great Observatories program. Check it out. The Great Observatories program in the 90s, or it actually started in the 70s and 80s at its roots, was the idea that we needed to have a suite of instruments in orbit around our world that would allow us to study the universe across the electromagnetic spectrum. We found ourselves able for a period of time to use the Compton X-ray Observatory, the Hubble Space Telescope, which is somehow still working, the Spitzer Infrared Observatory. All of these things, Compton was gamma rays. All of these things, including the Chandra X-ray Observatory, allowed us to reimagine our universe by providing us with new data. But one by one, each of these missions has moved past, and in the case of Compton and Spitzer, passed on from its end of mission. Hubble is having regular problems, and while Chandra is still going strong, we now have new technologies that allow us to improve on what it's able to do. With Astro 2020, the current Decadal Survey, we imagine a future where we're going to have the Nancy Grace Roman Telescope, originally called WFIRST, up there observing with its 2.6-meter mirror in the near-infrared. We're going to have a new generation X-ray observatory that has been named Athena. We're going to have a mission that will be observing in wavelengths like what Hubble was doing, looking in the ultraviolet, the optical, and the infrared. And this mission, which is a combination of the current plans for HabEx and LUVOIR, this new combined mission will be able to image planets and give us a new view on all these worlds coming into being. But the future we're dreaming isn't limited to what gets done from orbit. We are also imagining a new future here on the planet Earth, with a next generation very large array getting built, with upgraded receivers, upgraded dishes, upgraded everything, including taking our current very long baseline array, which is scattered across North America, and improving it into something that will give us a deeper, more sensitive, better view on the sky with new imaging capabilities. We're looking at upgrading our gravitational wave detectors and even building massive tens of meters telescopes in both the northern and southern hemisphere. The next amazing decade, which is apparently 8.5 years long, is starting now. And I can't wait to see what happens. But until then, after the break, we're going to be back to tell you what you can do tonight if you go out and look up. Stay tuned. This week in What's Up is the Leonid meteor shower. These meteors peak early next week, November 17th. To find them, look for the bright star Regulus in the east, low in the early morning. The radiant or apparent point in the sky where the meteors come from is up and to the north of Regulus, in the middle of the arc of stars that appear to form the lion's head. The source of the material for the Leonids meteor shower is Comet 55P Tempel-Tuttle. We will have excellent finding charts on our website, dailyspace.org. Also up this week are the planets, and they won't stay up for too much longer. Look to the south for Venus, Jupiter, Saturn, and the Moon, all in a line going up from west to east. The Moon is almost full, which will wash out most of the Leonids, unfortunately, but should still provide enough contrast to see small details on the surface in a telescope. Jupiter and Saturn are unaffected by the Moon's brightness. So get out there, look up, enjoy everything the sky has to offer. We are almost done, but before we go, we have a camera to recommend that, or at least a lens that just might make your next observing run all that much better. Stay tuned.
To wrap up this week, I'm going to present a review of a lens I recently rented for my mirrorless Canon EOS RP, the Canon RF 16mm f2.8 STM. Engineering is a series of compromises, accepting some bad things to prevent other good things. Not everything can be perfect, and close to perfect things are really expensive. The Canon RF 16mm f2.8 is marketed as compact, versatile, speedy, and affordable, and these outline the compromises in its design. In my brief one rental of the lens, I encountered all of these, and my overall impression is that it's good for what it is. You shouldn't expect miracles. It's not the $2,400 RF 1535mm f2.8. The RF 16mm is only $300. That's very good for a camera system mainly consisting of lenses in the $1,000 to $2,000 or more range. The lens body of the 16mm f2.8 itself is the same as the RF 50mm f1.8, taking advantage of the economies of scale of that so-called standard production lens's mass production. That is part of what makes it cheap. It's small, something only possible because of the 20mm flange distance of the mirrorless RF mount, which allows larger lens elements to be placed closer to the sensor. This is an advantage over DSLRs, which require about twice the flange distance to account for the mirror box. This distance makes ultra-wide lenses on DSLRs larger and more expensive, out of reach for a hobbyist. First, two good things about the Canon RF 16mm f2.8. The f2.8 aperture is nice and bright and allows you to have a very short depth of field that results in beautiful bokeh and use lower ISOs for cleaner images. Another good thing about the lens is it is fast. It has fast and accurate autofocus. Other RF lenses that I have used with the SDM type motor have lots of trouble finding focus, particularly at close distances. I did not have that problem with the RF 16mm f2.8. With the lens body, we arrive at the first major compromise in the design. The lens only has one adjustable ring on it, which combines the functions of the manual focus and control rings, the latter which allows you to change a function that you set it to, like white balance, ISO, and exposure compensation, among others. The lens body has one switch, which changes the behavior of the ring between control and focus. I don't mind this compromise because I don't use the control ring or manual focus often. The most significant compromise of the lens is in its optical design, 9 elements in 7 groups, according to the specifications. Technically, the image quality is not good. The barrel distortion and aberration where magnification decreases from the center of the image out is bad enough that it looks like a fisheye lens. And vignetting where the corners of the image are dark because the lens does not illuminate them is also not great. And the ability to turn off in-camera corrections is disabled for both the raw images, JPEGs, and in Canon's official software because of this. If you go out of your way to open a raw file without any of the corrections turned on in third-party software, you will see these problems. The in-camera corrected JPEGs look fine, except in the corners, which are stretched to correct for the barrel distortion. At f2.8, the corners of the image are soft and even show coma on point sources at the edge. This gets a little better at f11, the diffraction limit for the sensor on the Canon RP. The center of the image, most important to most photographers, is good at f2.8. Another compromise is that the lens does not have optical stabilization, but that's not a big deal. Stabilization would have increased the price a lot, and the large aperture still permits short exposures to avoid blurring due to vibration. Stabilization is more of a concern for longer focal length lenses where a tiny vibration can result in a lot of blurring in the image. Canon also markets this lens for astrophotography, but I did not get a chance to take the one I rented out under the stars due to clouds. My rental lens also did not include the Canon-made lens hood, as is currently in short supply, like many other things in the current pandemic supply chain crunch. Like all non-L series lenses, Canon does not include a lens hood with the RF 16mm f2.8 when you purchase it. Hoods are important for ultrawide lenses to effectively control flare, but I didn't have any problems with that one. In general, I don't use Canon-made hoods. Third-party lens hoods are just as good for a small fraction of the price of the Canon-made ones. I'm going to conclude my review with one more good thing about the Canon RF 60mm f2.8. It has a higher than average reproduction ratio of 0.25x, meaning that you can fill the frame with something 144mm wide at the minimum focus point of 13 centimeters. 1 times magnification being defined as filling the frame with something the size of the sensor, or 36mm wide for a full frame camera like the RP. Real macro lens, having that magnification on an ultra-wide lens is novel and a useful feature for close-ups, which is what I like to use an ultra-wide lens for. Overall, I was happy with the RF 16mm f2.8, but it's kind of a specialized lens that most people probably won't need to have, but could buy with little justification because of its low price. At $300, it's very affordable and has decent image quality, especially with camera-corrected JPEGs. It's not a lens aimed at professionals and doesn't try to be. If you want to purchase one after listening to this review, you can do so from Amazon using our affiliate link, which will be in the show notes for this episode. This has been The Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.